May 12, 1940. The Reich Air Ministry, Berlin. Hermann Wilhelm Göring, resplendent in his powder blue Luftwaffe uniform adorned with the Pour le Mérite at his throat, threw back his head and released a laugh that echoed through the marble halls of Nazi power. Before him lay intercepted intelligence reports detailing President Franklin Roosevelt's audacious proclamation to Congress just weeks earlier. America would build 50,000 aircraft per year. 50,000. The Reichsmarschall's corpulent frame shook with mirth as he slammed his jeweled fist on the mahogany desk. 50,000 planes! He bellowed to his assembled staff officers. The Americans think they can match the industrial might of the Reich with their Hollywood fantasy numbers. They build cars and refrigerators, not fighters. They are a nation of shopkeepers and jazz musicians. Outside his window, the spring air carried the distant rumble of Heinkel. He 111 seconds practicing formation flights over the Brandenburg countryside. Their twin engines, a mechanical symphony of German engineering superiority. Göring had every reason to be confident his Luftwaffe had just crushed Poland in 18 days and was preparing to humble France. What he could not foresee, as he dismissed those intelligence reports with a wave of his ring-adorned hand, was that he had just witnessed the opening salvo of the most catastrophic industrial miscalculation in human history. What Göring failed to comprehend in that moment of supreme hubris was not merely a number on a page, but the awakening of an industrial colossus that would systematically dismantle every assumption about warfare, production, and national capability that had governed European thinking for centuries. Roosevelt's call for 50,000 aircraft wasn't just a production target. It was a declaration of industrial war against the very concept of scarcity itself. The Americans wouldn't just meet that seemingly impossible goal. They would obliterate it, burying the Luftwaffe under an avalanche of aluminum, steel, and mass-produced devastation that would redefine the mathematics of modern conflict. This wasn't simply about building more planes than Germany. It was about unleashing a form of industrial warfare so overwhelming, so incomprehensibly abundant, that it would render traditional European concepts of military production obsolete. The story of what followed represents perhaps the most complete ideological demolition in military history, not just the defeat of German arms, but the systematic annihilation of the very worldview that made Göring's laughter possible. The foundations of Göring's confidence weren't entirely without merit in that spring of 1940. German aircraft production in 1939 had reached an impressive 8,295 planes, a figure that represented the pinnacle of European industrial organization and technical precision. The Messerschmitt Bf 109, with its Daimler-Benz DB 601 engine generating 1,175 horsepower, dominated European skies with a maximum speed of 373 miles per hour and a service ceiling of 36,090 feet. German factories like those at Regensburg and Wiener Neustadt operated with clockwork efficiency, their assembly lines producing aircraft of acknowledged technical superiority. The Focke-Wulf 190, entering service in 1941, would mount 4 MG-151 over 20 cannons and 2 MG-131 machine guns, a weapons package that could tear apart any Allied fighter of its day. These weren't just machines. They were manifestations of German Kultur, products of a society that had elevated engineering to an art form. When Göring surveyed his domain from the windows of Karrenhall, his hunting lodge north of Berlin, he could see me 110 seconds practicing dive-bombing runs over the Schorfheide forest, their twin engines screaming across the pine canopy like mechanical Valkyries. The Reichsmarschall possessed 4,093 combat aircraft as of September 1939, more than the combined air forces of Britain and France. His pilots were veterans of Spain and Poland. Their aircraft, the products of factories that had been secretly developing military technology since the late 1920s. What rational calculation could suggest that America, a nation that had produced exactly 2,195 military aircraft in 1939, could possibly threaten this established supremacy? Yet even as Göring's laughter died in the spring air of Berlin, profound forces were already stirring across the Atlantic that would transform his confidence into catastrophic delusion. On January 3, 1941, at the Willow Run facility in Ypsilanti, Michigan, Ford Motor Company broke ground on what would become the largest manufacturing complex in human history, a single building covering 3.5 million square feet, stretching 1.5 miles in length and 0.5 miles in width. The facility was designed by Albert Kahn, the architect of mass production, who had revolutionized industrial construction with his daylight factories and steel frame designs. But Willow Run wasn't intended to produce automobiles. It was engineered for the systematic mass production of consolidated B-24 Liberator heavy bombers. Henry Ford, the man who had democratized transportation with the Model T, announced that his factory would produce one 4-engine bomber every hour, a production rate that German aviation officials dismissed as American showboating. What they failed to grasp was that Ford wasn't simply scaling up existing production methods. He was fundamentally reimagining the relationship between manufacturing and warfare. The B-24 Liberator, with its 4 Pratt & Whitney R1000, 830 twin Wasp engines, producing 1,200 horsepower each, represented a 65,000-pound weapons system capable of carrying 8,800 pounds of bombs across a combat radius of 1,540 miles. Ford's engineers had dissected this complex aircraft into 1.2 million individual components, then designed machinery and workflows that could transform raw aluminum ingots into operational bombers with assembly line precision. By the time Willow Run reached full production in 1943, the factory was consuming 1,398 tons of aluminum per day and employing 42,331 workers across 3 shifts, more people than inhabited most German cities. The scope of American industrial transformation wasn't limited to a single facility or even a single company. It represented a complete reordering of national productive capacity that dwarfed anything attempted in human history. At the Boeing plant in Seattle, the B-17 Flying Fortress production line stretched across 2.2 million square feet of factory space, where 30,000 workers assembled bombers capable of delivering 4,500 pounds of bombs to targets 2,000 miles away. The B-17G model mounted 13 .50-caliber Browning M2 machine guns in powered turrets, creating interlocking fields of fire that could shred attacking fighters. But statistics barely conveyed the revolutionary nature of what was occurring. American industry was solving problems of scale and complexity that had never been contemplated. At North American Aviation in Los Angeles, engineers designed the P-51 Mustang fighter around the Packard V-1650 Merlin engine, a license-built version of the legendary Rolls-Royce power plant that generated 1,695 horsepower and propelled the sleek fighter to 437 miles per hour at 25,000 feet. The P-51's laminar flow wing, manufactured using precision tooling and advanced metallurgy, provided the aircraft with a combat radius of 1,650 miles, enabling American fighters to escort bombers all the way to Berlin and back. North American's factory in Inglewood could produce 15 complete P-51 seconds per day, each aircraft requiring 22,000 man-hours of labor, coordinated across 125 subcontractors. When multiplied across dozens of manufacturing facilities from California to Connecticut, American aircraft production represented an industrial mobilization of unprecedented magnitude, not just building airplanes, but fundamentally restructuring the relationship between industrial capacity and military power. The mathematical progression of American aircraft production began to assume proportions that challenged basic comprehension. In 1940, as Göring laughed at Roosevelt's 50,000 plane target, American factories produced 12,804 aircraft. By 1941, that figure had escalated to 26,277 planes. The following year saw 47,836 aircraft roll off American assembly lines, approaching Roosevelt's supposedly impossible goal. But the avalanche was just beginning to gather momentum. In 1943, American factories produced 85,898 aircraft. In 1944, The peak year of production, that number reached a staggering 96,318 planes, nearly doubling Hitler's entire Air Force production for the entire war in a single year. These weren't just training aircraft or light observation planes padding the statistics. They were sophisticated combat machines representing the pinnacle of aeronautical engineering. The numbers defied every economic model that German planners possessed. How could a nation simultaneously produce 88,430 tanks, 2,382 naval vessels, 434,000 trucks, and nearly 100,000 aircraft in a single year, while maintaining civilian production levels that exceeded Germany's peacetime economy? The answer lay in America's transformation from a consumer economy to what economist John Kenneth Galbraith would later term the industrial war machine, a productive apparatus so vast and efficient that it could simultaneously equip its own forces, supply its allies, and overwhelm its enemies through sheer material abundance. By 1944, American aircraft factories were completing one warplane every 4 minutes around the clock, 7 days a week, a production rate that rendered German attempts at replacement impossible. The human dimension of American aircraft production revealed an organizational achievement that transcended mere manufacturing. It represented the mobilization of an entire society's intellectual and physical resources toward a single objective. At the Vultee aircraft plant in Nashville, Tennessee, women who had never seen an airplane before Pearl Harbor became precision riveters capable of installing 2,400 rivets per shift in the aluminum skin of A-31 Vengeance dive bombers. Rosie the Riveter wasn't just a propaganda symbol. She was a statistical reality reflected in employment figures that showed women comprising 65% of the aircraft industry workforce by 1943. At Consolidated Aircraft in San Diego, the B-24 Liberator production line employed teams of workers whose previous experience included farming, teaching, and shopkeeping, yet who mastered the complexities of installing Sperry Ball turrets, Norden bomb sights, and radar systems with methodical precision. The P-47 Thunderbolt, manufactured by Republic Aviation in Farmingdale, Long Island, weighed 17,500 pounds fully loaded and mounted 8 50-caliber machine guns capable of firing 1,200 rounds of ammunition in coordinated bursts. Each aircraft required 35,000 individual components sourced from 1,147 subcontractors across 46 states, a supply chain of such complexity that it required IBM punchcard machines and early computers to coordinate parts delivery and quality control. The Pratt & Whitney R2800 double wasp engine that powered the P-47 generated 2,800 horsepower through 18 cylinders arranged in 2 radial banks, requiring precision manufacturing tolerances measured in thousandths of an inch across components ranging from cylinders to crankshafts. American factories weren't just building airplanes, they were creating an integrated system of suppliers, workers, and technology that transformed raw materials into finished weapons with industrial efficiency that exceeded anything achieved before or since. The technological sophistication embedded within American mass production represented an evolution in warfare that German observers consistently underestimated. The Boeing B-29 Superfortress, which entered service in 1944, incorporated pressurized cabins that allowed crews to operate at altitudes exceeding 33,000 feet, well above the service ceiling of German interceptors. Each B-29 required 55,000 man-hours to construct and incorporated innovations, including remotely controlled gun turrets, advanced radar bombing systems, and Wright R-3000, 350 engines, producing 2,200 horsepower each, through innovative cylinder head cooling and supercharging systems. The aircraft's maximum takeoff weight of 140,000 pounds and bomb load capacity of 20,000 pounds represented a quantum leap in strategic bombing capability. Yet Boeing was producing these technological marvels at a rate of 16 aircraft per month by late 1944. American engineers had solved production challenges that German designers hadn't even contemplated. The P-80 Shooting Star, America's first operational jet fighter, flew its maiden flight on January 8, 1944, demonstrating that American industry could not only match German technological innovation, but scale it to mass production levels that the Luftwaffe could never achieve. While Germany struggled to produce a handful of Me-262 jets due to material shortages and manufacturing bottlenecks, Lockheed was preparing production lines capable of building P-82s by the hundreds. The mathematical reality was becoming undeniable. American industry had achieved a combination of quantity, quality, and technological advancement that rendered traditional concepts of military-industrial balance obsolete. The geographic scope of American aircraft production revealed the true magnitude of the industrial mobilization that Göring had so casually dismissed. From the Boeing plants in Seattle, where B-17 seconds and B-29 seconds took shape under the gray Pacific Northwest skies, to the Grumman facilities on Long Island, where F-6F Hellcats and TBF Avengers rolled off assembly lines destined for Pacific carrier decks, the entire North American continent had been transformed into an aircraft manufacturing complex. The Consolidated Aircraft Facility in Fort Worth, Texas, covered 4.2 million square feet and employed 31,000 workers producing B-24 Liberators around the clock in 3 shifts. North American Aviation's plant in Kansas City specialized in B-25 Mitchell medium bombers, twin-engine aircraft capable of carrying 3,000 pounds of bombs across 1,350 miles of hostile territory. The Curtiss Wright factory in Buffalo, New York, manufactured P-40 Warhawk fighters that would serve with distinction from the deserts of North Africa to the jungles of Burma. Bell Aircraft in Buffalo produced P-39 Airacobras and P-63 King Cobras, fighters with unique mid-engine configurations that provided exceptional maneuverability. Lockheed's Burbank facility, nestled in the hills above Los Angeles, created the P-38 Lightning, a twin-boom, twin-engine interceptor capable of 414 miles per hour and armed with one 20mm cannon and 4 50-caliber machine guns concentrated in the nose for devastating firepower. Each of these facilities represented not just a factory, but a complete industrial ecosystem encompassing raw material processing, component manufacturing, final assembly, testing, and delivery, all coordinated through a supply chain that spanned the continent and involved millions of workers, thousands of companies, and unprecedented levels of capital investment. The strategic implications of American aircraft production became apparent not through individual victories, but through the systematic mathematical attrition that ground down German air power day by day, month by month, year by year. By 1943, American B-24 Liberators were conducting daylight precision bombing missions deep into German-occupied Europe, protected by swarms of P-47 Thunderbolts and P-51 Mustangs that could escort the bombers all the way to their targets and back. The famous Schweinfurt-Regensburg mission of August 17, 1943, saw 376 B-17 flying fortresses attack German ball-bearing and aircraft factories protected by 240 P-47 fighters, a single-day commitment of 616 aircraft that exceeded the total strength of many national air forces. German defenders shot down 60 American bombers and 3 fighters during the mission, inflicting painful losses on the 8th Air Force. But American factories replaced those losses within a week, while German aircraft production never recovered from the destruction of the Messerschmitt facility at Regensburg. The mathematics of attrition warfare had shifted decisively in America's favor, not because American aircraft were individually superior, but because American industry could absorb losses and continue operations at a scale that German planners found incomprehensible. When Luftwaffe ace pilots like Adolf Galland shot down American bombers, they discovered that the wreckage contained components manufactured in dozens of different states by workers who had never seen combat yet, who were systematically producing the tools of German defeat with assembly line efficiency. The emergence of American naval aviation represented perhaps the most dramatic manifestation of industrial warfare's transformation of military balance. The Essex-class aircraft carriers, each displacing 36,000 tons and capable of operating 90 aircraft, rolled off the slipways of American shipyards with mechanical regularity. 24 carriers completed between 1942 and 1,946, each one representing a floating air base more powerful than most nations' entire air forces. The Grumman F-6F Hellcat, designed specifically for carrier operations, mounted 6 50-caliber machine guns and possessed a maximum speed of 391 miles per hour, powered by a Pratt & Whitney R-2800 engine. In the hands of American naval aviators, the F-6F achieved a kill ratio of 19-1 against Japanese aircraft, not because American pilots were necessarily superior, but because American industry could provide them with aircraft available in overwhelming numbers, supported by comprehensive training programs, and equipped with advanced technology, including radar and improved communications equipment. The Battle of the Philippine Sea, fought June 19-20, 1944, saw Task Force 58 deploy 15 carriers, operating 956 aircraft, more planes than Germany possessed on the entire Eastern Front at that time. Japanese pilots dubbed the engagement the Great Marianas Turkey Shoot, as American fighters systematically destroyed 400 Japanese aircraft in 2 days of combat, while losing only 29 of their own. The mathematical progression was devastating. Japan lost experienced pilots and irreplaceable aircraft, while American carriers immediately launched replacement planes, flown by pilots trained in the vast aviation schools that American industry had constructed across the continental United States. The transformation of American civilian aviation infrastructure into military production capability revealed the true scope of industrial mobilization that Göring had failed to comprehend. Airlines like Eastern, American, and TWA contributed not just their aircraft and pilots to the war effort, but their maintenance facilities, trained mechanics, and operational expertise. The massive aircraft modification centers established at places like Oklahoma City and San Antonio could strip down, rebuild, and upgrade hundreds of aircraft, simultaneously transforming B-24 seconds into long-range reconnaissance platforms, converting C-47 transports into airborne command posts, and installing advanced radar systems in night fighters. The Air Transport Command, established in 1942, operated 3,700 aircraft across global supply routes that delivered everything from engines to ammunition to American bases worldwide. The hump airlift over the Himalayas from India to China involved 650 transport aircraft flying 1,200 sorties per month over some of the world's most dangerous terrain, yet it represented just one minor component of TAME, America's global aviation logistics network. American industry hadn't just built aircraft, it had constructed a comprehensive system for deploying, maintaining, and operating air power on a planetary scale. German forces discovered this reality the hard way when they encountered American aircraft in every theater, from Alaska to Australia, all maintained to identical standards and supplied through logistics chains that functioned with mechanical precision regardless of geography or weather conditions. The personnel dimension of American aviation revealed an organizational achievement that transcended simple industrial production. The Army Air Forces Training Command operated 77 flying schools, 57 technical schools, and 30 flexible gunnery schools across the United States, graduating 193,440 pilots, 50,976 bombardiers, 45,654 navigators, and 364,000 gunners and crew members during the war years. These weren't hastily trained recruits thrown into combat, but professionally educated specialists who understood their aircraft systems, weapons, and tactics through comprehensive programs that lasted 8 to 12 months. The B-24 Liberator crew training program at Alamogordo, New Mexico, required 215 hours of flight training, 180 hours of ground school, and 45 hours of gunnery practice before crews were certified combat-ready. American pilots arrived in combat theaters with more flight hours than their German counterparts possessed after 2 years of combat experience. The standardization of training meant that a P-51 pilot trained in Texas could immediately operate from bases in England, Italy, or the Pacific with identical aircraft, procedures, and support equipment. German pilots, by contrast, often flew aircraft that differed significantly between production batches due to material shortages and improvised manufacturing changes. The systematic nature of American training production created a self-reinforcing cycle. Experienced pilots became instructors who trained more pilots, who became combat veterans who returned to train still more pilots, creating an exponential increase in overall pilot quality and availability. By late 1944, the cumulative weight of American aircraft production was reshaping the fundamental character of aerial warfare across every theater of operations. In the European theater of operations, the 8th Air Force alone possessed 2,400 heavy bombers and 1,500 fighters, more aircraft than Germany had deployed during the entire Battle of Britain. The 15th Air Force, operating from bases in Italy, added another 1,200 B-24 Liberators and 850 P-51 Mustangs to the strategic bombing campaign. American tactical air forces supporting ground operations in France and Germany fielded an additional 3,000 fighters and fighter bombers. The sheer scale of operations had become astronomical. On Christmas Eve 1944, the 8th Air Force launched 2,034 bombers and 853 fighters against German transportation targets, a single-day commitment exceeding the total aircraft strength that most nations possessed throughout the entire war. In the Pacific Theater, American carrier aviation had achieved similar levels of overwhelming superiority. Task Force 38, operating off the coast of Japan in early 1945, deployed 16 fleet carriers and 9 light carriers, operating 1,400 aircraft, a concentration of air power that could devastate entire Japanese cities in single raids. The mathematical reality had become undeniable. American industry was producing aircraft faster than enemy forces could destroy them, creating a cumulative advantage that grew larger with each passing month. The qualitative evolution of American aircraft design during the war years demonstrated that mass production hadn't compromised technological advancement. If anything, the scale of American manufacturing had accelerated innovation by providing resources for rapid prototyping, testing, and refinement. The P-51D Mustang, entering service in 1944, incorporated lessons learned from thousands of combat missions flown by earlier variants, resulting in an aircraft that combined 437 miles per hour speed, 1,650-mile range, and 6 50-caliber machine guns in a package that German pilots learned to fear and respect. The bubble canopy provided 360-degree visibility, while the Packard Merlin engine delivered reliable power across the full flight envelope. American engineers hadn't just built a superior fighter. They had created a weapons system optimized for mass production while incorporating the most advanced technology available. The F-4U Corsair, manufactured by Chance Vought, demonstrated similar evolution from problematic early variants to a carrier-capable fighter bomber that achieved a 11:1 kill ratio against Japanese aircraft. The Corsair's distinctive inverted gull wing wasn't just an aesthetic choice, it was an engineering solution that allowed the massive Pratt & Whitney R2800 engine to be mounted while maintaining adequate ground clearance for the large propeller. By 1945, American factories were producing aircraft that surpassed their European counterparts in every measurable category: speed, range, firepower, reliability, and manufacturability. The global deployment of American-manufactured aircraft represented a logistical achievement that rivaled the production miracle itself. Lend-Lease deliveries provided the Soviet Union with 14,795 aircraft, including 9,438 fighters that equipped elite units like the 9th Guards Fighter Aviation Regiment. British forces received 38,811 American aircraft, ranging from P-51 Mustangs that served with the RAF as far afield as Burma to B-25 Mitchells that flew with the South African Air Force in Italy. Free French squadrons operated P-47 Thunderbolts, while Chinese air units flew P-40 Warhawks supplied through the dangerous hump airlift over the Himalayas. American aircraft served in every climate and geography on Earth, from the Arctic tundra of Alaska to the tropical jungles of New Guinea, all maintained through a supply chain that delivered spare parts, ammunition, and technical support with assembly line reliability. The Douglas C-54 Skymaster, a four-engine transport derived from the civilian DC-4 airliner, became the backbone of global air logistics, capable of carrying 22,000 pounds of cargo across 3,500-mile ranges. American transport aircraft logged 746,000 flights, covering 1.8 billion miles during the war years, distances that would circumnavigate the Earth 72,000 times. The mathematical scope of American aviation logistics had transcended traditional concepts of military supply. It represented the application of industrial-scale systems thinking to the problems of global warfare. The economic foundations supporting American aircraft production revealed the true magnitude of the industrial mobilization that Göring had so carelessly dismissed in 1940. Aircraft manufacturing consumed 16.4% of America's total industrial production by 1944, requiring 1.345 million workers and $45 billion in capital investment, figures that exceeded the gross national product of most European nations. The aluminum industry, essential for aircraft construction, increased production from £412 million in 1940 to £1.5 billion in 1943, requiring the construction of massive new smelting facilities powered by hydroelectric dams across the Tennessee Valley and Pacific Northwest. The precision ball bearing industry, critical for aircraft engines and propellers, expanded production capacity by 800%, through facilities that operated around the clock with precision measured in thousandths of an inch. American universities conducted research programs that advanced metallurgy, aerodynamics, electronics, and manufacturing processes, creating technological improvements that were immediately incorporated into production aircraft. The Massachusetts Institute of Technology's Radiation Laboratory developed airborne radar systems that gave American bombers all-weather bombing capability, while California Institute of Technology's Jet Propulsion Laboratory pioneered rocket and jet engine technology that would dominate post-war aviation. The integration of academic research, industrial production, and military requirements created a technological ecosystem that could simultaneously increase quantity and improve quality, a combination that German planners had assumed was impossible. The human cost of German resistance to American industrial supremacy became apparent through combat statistics that reflected mathematical reality rather than martial rhetoric. Luftwaffe pilot losses during 1944 reached catastrophic proportions as American fighters achieved tactical superiority through overwhelming numbers rather than individual heroics. On Black Thursday, October 14, 1943, German fighters shot down 60 B-17 Flying Fortresses during the second Schweinfurt raid, but American factories had already produced replacements before the damaged bombers crash-landed in England. German ace pilots like Erich Hartmann and Gerhard Barkhorn achieved impressive individual victory counts against Soviet and American aircraft, but their personal successes couldn't offset the statistical reality of American production. For every German ace who shot down 100 Allied aircraft, American factories produced 1,000 replacements flown by adequately trained pilots, supported by comprehensive logistics networks. The Luftwaffe's pilot training programs, shortened to 150 hours of flight time due to fuel shortages, produced aviators who were systematically outmatched by Americans who had received 400 hours of training in aircraft that were being constantly improved and upgraded. German pilots flew the same Messerschmitt Bf-109 variants in 1944 that had achieved success in 1940, while their American opponents piloted P-51D Mustangs that incorporated 4 years of combat experience and technological development. The mathematical progression of attrition warfare had become inexorable. Germany was losing experienced pilots faster than training programs could replace them, while American pilot production exceeded losses by substantial margins. As 1,944 transitioned into 1,945, the cumulative impact of American aircraft production had fundamentally altered the strategic balance of the war in ways that transcended simple numerical comparisons. The combined bomber offensive had destroyed German aviation fuel production facilities, reducing Luftwaffe operations to a fraction of their 1,943 levels despite desperate attempts to disperse and camouflage remaining refineries. The systematic destruction of German aircraft factories by B-17 seconds and B-24 seconds had reduced monthly production from 3,000 aircraft in 1944 to fewer than 1,000 by early 1945. German pilots, when they could obtain fuel for training flights, discovered that their opponents possessed overwhelming technological and numerical advantages. American P-51 Mustangs operated from advanced bases in Belgium and France, providing escort for bombing missions that penetrated deep into German territory with impunity. The 8th Air Force's shuttle bombing missions, which attacked German targets and then landed at bases in the Soviet Union before returning via different targets, demonstrated the global reach of American air power. German anti-aircraft defenses, despite deploying 88mm flak guns in quantities that exceeded 10,000 weapons, couldn't prevent American bombers from systematically destroying remaining industrial capacity. The mathematical reality had become undeniable. American aircraft production had achieved levels that rendered German resistance strategically meaningless. The technological sophistication of American aircraft entering service in 1945 demonstrated that quantity production hadn't compromised innovation. Instead, the scale of American manufacturing had accelerated technological development to unprecedented levels. The Boeing B-29 Superfortress, operating from bases in the Mariana Islands, possessed pressurized cabins, remote-controlled gun turrets, and radar bombing systems that allowed precision attacks from altitudes exceeding 30,000 feet. Each B-29 represented 600,000 man-hours of labor and incorporated 55,000 individual components manufactured by 1,500 subcontractors across the United States. The Wright R3000, 350 engines powering the B-29 generated 2,200 horsepower each, through advanced supercharging and cylinder cooling systems that pushed aircraft performance beyond anything previously achieved. The Lockheed P-80 Shooting Star, America's first operational jet fighter, demonstrated that American industry could master jet propulsion technology and prepare for mass production while Germany struggled to build a handful of Mi-262 seconds. American engineers weren't just building aircraft. They were systematically advancing the state of aeronautical technology through resources and manufacturing capability that exceeded anything available to German designers. The P-80's General Electric 140 turbojet, producing 4,000 pounds of thrust, incorporated metallurgical advances and precision manufacturing techniques that German jet engines couldn't match despite theoretical superiority in some design areas. In the pre-dawn darkness of April 20th, 1945, Adolf Hitler's 56th birthday, Reich Air Ministry officials huddled in the ruins of Berlin, surrounded by the rubble of what had once been the heart of German aviation power. Outside, American and British bombers droned overhead with mechanical regularity, their engines providing a constant soundtrack to German defeat. The statistics were overwhelming and undeniable. American factories had produced 324,750 aircraft during the war years, including 99,950 fighters, 97,592 bombers, 23,929 attack aircraft, and 103,279 trainers, transports, and support aircraft. German production for the entire war totaled approximately 119,000 aircraft of all types, less than half of American output, and far below the industrial capacity required to sustain operations against opponents possessing unlimited replacement capability. The mathematical progression told the story of complete industrial defeat. For every German aircraft shot down, American factories had produced 3 replacements. For every German pilot lost in combat, American training programs had graduated 5 new aviators. For every gallon of aviation fuel consumed by the Luftwaffe, American refineries had produced 10 gallons for Allied operations. The industrial warfare that Göring had dismissed as impossible had systematically dismantled German air power through overwhelming material superiority rather than individual heroics or technological breakthroughs. The personal revelations of German aviation officials during the war's final months provided the ultimate testimony to American industrial supremacy. Albert Speer, Hitler's armaments minister, wrote in his diary on March 15, 1945, "The American production figures we dismissed as propaganda in 1940 have proven to be conservative estimates. They are not just building more aircraft than we anticipated. They are building aircraft better than anything we can produce, while simultaneously improving design and manufacturing processes. Our pilots report that American fighters possess superior performance, reliability, and equipment. We cannot match their production quantities, and we can no longer match their quality. The industrial war has been lost." Generaloberst Adolf Galland, commander of German fighter forces, documented his growing desperation in combat reports throughout 1944. American fighters appear over German territory in formations of 500 to 800 aircraft. Our pilots, when we have fuel for operations, encounter opponents flying aircraft that surpass our own in speed, range, and firepower. The P-51 Mustang can escort bombers to any target in Germany and engage our interceptors with fuel reserves that allow extended combat. Our pilots are fighting with obsolete aircraft against enemies possessing unlimited resources. The testimony was consistent across all levels of German aviation. American industry had achieved production levels that rendered resistance futile, while simultaneously advancing technology to levels that German designers couldn't match. But perhaps the most profound acknowledgement of defeat came from Hermann Göring himself, the man who had laughed so confidently at American production targets 5 years earlier. During his interrogation by Allied intelligence officers on May 10, 1945, 3 days after Germany's surrender, the former Reichsmarschall provided a statement that summarized the complete collapse of German aviation power. "We completely underestimated American industrial capacity. When Roosevelt announced his plan to build 50,000 aircraft per year, we calculated that it was impossible based on our understanding of aircraft manufacturing. We assumed that Americans built automobiles, not sophisticated military aircraft. We were wrong about everything. They didn't just build 50,000 planes per year, they built 100,000 per year while simultaneously producing tanks, ships, and equipment for their allies. Their aircraft surpassed ours in performance while being produced in quantities that we couldn't comprehend. The P-51 Mustang could outfight our best interceptors while flying farther than our bombers. Their B-24 Liberators attacked our cities in formations larger than our entire bomber force. American pilots arrived over German territory better trained than our veterans, flying superior aircraft supported by unlimited resources. We lost the war because we failed to understand the nature of industrial warfare. We were fighting with the production methods of 1918 against enemies who had created entirely new forms of manufacturing. The laughter stopped long ago. The mathematical legacy of American aircraft production during World War II represented more than military victory. It constituted a fundamental transformation in the relationship between industrial capacity and national power. The 324,750 aircraft produced by American factories between 1940 and 1945 didn't just win a war. They established the foundation for American global dominance that would persist throughout the Cold War and beyond. The Boeing B-29 seconds that ended the Pacific War through atomic bombing had been designed and manufactured using industrial processes that would evolve into commercial aviation systems serving global markets. The P-80 Shooting Star, America's first operational jet fighter, led directly to the F-86 Sabre, F-104 Starfighter, and ultimately to the aerospace systems that would put Americans on the moon. The supply chains, manufacturing techniques, and technological innovations developed for wartime aircraft production became the infrastructure supporting post-war economic expansion that dwarfed all competitors. The workers who had learned precision manufacturing building B-24 Liberators applied those skills to producing automobiles, televisions, and consumer goods that established American manufacturing supremacy across multiple industries. The research universities that had advanced aviation technology during wartime continued developing jet engines, electronics, and materials science that maintained American technological leadership for decades. The strategic implications of America's aircraft production achievement extended far beyond the immediate military victory over Germany and Japan. The demonstration that democratic societies could mobilize industrial resources more effectively than totalitarian regimes fundamentally altered international perceptions of relative national strength. The Soviet Union, despite receiving 14,795 American aircraft through Lend-Lease, never achieved comparable production levels, despite possessing vast natural resources and population. Britain, the birthplace of industrial revolution, produced approximately 131,000 aircraft during the war years, impressive by European standards, but less than half of American output. The mathematical reality was undeniable. American industry had achieved production levels that exceeded the combined output of all other major powers, while simultaneously maintaining civilian living standards that surpassed wartime conditions in other nations. The economic foundations supporting this industrial miracle, abundant natural resources, advanced transportation systems, sophisticated financial markets, technological universities, and democratic institutions that could coordinate massive undertakings without coercion, became the template for post-war development that other nations attempted to emulate. The aircraft factories that had produced P-51 Mustangs and B-29 Superfortresses became the prototypes for manufacturing systems that would dominate global markets in industries ranging from electronics, pharmaceuticals. The human dimensions of American aircraft production revealed organizational capabilities that transcended manufacturing efficiency. They demonstrated how democratic societies could harness individual talents and collective resources toward shared objectives without sacrificing personal freedoms or cultural diversity. The 1.345 million Americans who worked in aircraft factories during World War II included immigrants from dozens of nations, women entering industrial employment for the first time, African Americans migrating from agricultural regions to urban manufacturing centers, and skilled craftsmen adapting traditional techniques to modern production requirements. The Rosie the Riveter phenomenon wasn't just about women building aircraft. It represented the systematic inclusion of previously underutilized human resources in national productive capacity. The training programs that taught former farmers to install radar systems in night fighters and converted schoolteachers into precision machinists demonstrated educational flexibility that totalitarian societies couldn't match. American aircraft workers possessed individual rights, labor protections, and economic opportunities that motivated productive effort through incentives rather than coercion. The quality of American aircraft demonstrated through superior performance in combat conditions worldwide reflected manufacturing systems that encouraged worker input, rewarded innovation, and maintained high standards through voluntary compliance rather than police state enforcement. The democratic foundations supporting American industrial mobilization proved more effective than fascist or communist alternatives, while preserving individual liberties and cultural institutions. The technological legacy of American wartime aircraft production established scientific and engineering capabilities that would dominate global aerospace development for generations. The research programs that advanced aircraft design during World War II, conducted at facilities including the National Advisory Committee for Aeronautics, NACA, Massachusetts Institute of Technology, California Institute of Technology, and dozens of university laboratories created knowledge bases that supported post-war innovations, ranging from commercial aviation to space exploration. The wind tunnels, computational facilities, and testing equipment developed for military aircraft became the infrastructure supporting civilian aerospace industries that generated millions of jobs and hundreds of billions in economic activity. The engineers who designed P-51 Mustangs and B-29 Superfortresses applied their expertise to creating Boeing 707 airliners, Lockheed Constellation transports, and Douglas DC-8 jets that revolutionized global transportation. The manufacturing techniques perfected in wartime aircraft factories, precision machining, quality control systems, supply chain coordination, and assembly line optimization became standard practices across American industry that maintained competitive advantages in global markets. The materials science advances that produced stronger aluminum alloys, more reliable engines, and advanced electronics for military aircraft generated commercial applications that transformed consumer goods, telecommunications, and computing systems. The global implications of American aircraft production supremacy fundamentally reshaped international relations and established patterns of alliance and dependency that persisted throughout the Cold War. Nations that had witnessed American industrial capacity during World War II understood that military confrontation with the United States would inevitably result in defeat through overwhelming material superiority rather than battlefield heroics. The Marshall Plan, which rebuilt European economies through American financial and technical assistance, demonstrated that the same industrial capacity that had produced 324,750 combat aircraft could be redirected toward peaceful reconstruction and economic development. American aircraft manufacturers like Boeing, Lockheed, and Douglas transitioned from military production to commercial aviation markets that established American dominance in global airline industries. The NATO alliance system created markets for American military aircraft that generated continuous revenue streams while maintaining technological superiority over potential adversaries. Nations seeking modern air forces discovered that American manufacturers could provide aircraft, training, spare parts, and technical support through integrated systems that competitors couldn't match. The economic relationships established through aircraft sales created political alliances that reinforced American global influence while generating resources for continued technological advancement. As the smoke cleared over the ruins of Berlin in May 1945, the mathematical finality of American industrial victory could no longer be disputed or minimized. Hermann Göring's confident laughter from that spring morning in 1940, when he had dismissed Roosevelt's call for 50,000 aircraft as fantasy, had been systematically demolished by production figures that exceeded even the most optimistic American projections. The Luftwaffe, once the terror of European skies, had been ground down not by superior individual aircraft or pilots, but by the relentless application of industrial capacity that transformed warfare from a test of military skill into a competition between manufacturing systems. American factories had produced not just more aircraft than Germany, but better aircraft built by workers who possessed freedoms and opportunities that totalitarian societies couldn't provide, while maintaining living standards that exceeded pre-war conditions. The P-51 Mustangs that escorted bombers over German territory, the B-29 Superfortresses that ended the Pacific War, and the thousands of transport aircraft that supplied global operations represented more than military hardware. They embodied an industrial philosophy that combined democratic values with technological innovation and organizational efficiency. The ultimate irony of Göring's miscalculation lay not just in the numbers, though American production of 324,750 aircraft versus Germany's 119,000 demonstrated the magnitude of his error, but in the complete reversal of assumptions about industrial capability and national character. The Americans, whom Göring had dismissed as manufacturers of consumer goods, had systematically out-engineered German designers, while simultaneously outproducing German factories by margins that defied comprehension. The P-51D Mustang, with its bubble canopy, laminar flow wing, and 1,650-mile range, represented aeronautical achievements that surpassed anything in the Luftwaffe inventory. The B-24 Liberator, rolling off assembly lines at Willow Run every hour, incorporated manufacturing innovations that German engineers couldn't match despite their reputation for technical precision. American pilots, trained in programs that provided more flight hours than German aces possessed after years of combat, arrived in European skies better prepared and better equipped than their opponents. The mathematical progression had become inexorable. American industry hadn't just met Roosevelt's seemingly impossible target of 50,000 aircraft per year. It had doubled that figure, while simultaneously producing tanks, ships, and equipment for allies worldwide. The laughter had died in the rubble of German cities bombed by aircraft that existed because Hermann Göring had fundamentally misunderstood the nature of American society and the relationship between democracy, industry, and national power. In the end, The story of American aircraft production during World War II represents more than military history. It constitutes a definitive demonstration of how industrial capacity, technological innovation, and democratic organization could combine to produce results that totalitarian societies couldn't match, despite possessing apparent advantages in centralized planning and resource mobilization. The 324,750 aircraft that rolled off American production lines between 1,940 and 1,945 weren't just weapons. They were manifestations of a social and economic system that could simultaneously wage global war, maintain domestic prosperity, advance scientific knowledge, and preserve individual liberties. Hermann Göring's laughter from that Berlin morning in May 1940 had been silenced not by propaganda or political rhetoric, but by the relentless mathematics of democratic industrial warfare, an avalanche of aluminum, steel, and American ingenuity that buried fascist assumptions about national strength beneath an overwhelming tide of mass-produced superiority. The lesson transcended aviation history. When democratic societies mobilize their full productive capacity toward common objectives, the results exceed what authoritarian alternatives can achieve through coercion and central planning. The aircraft that won World War II demonstrated that freedom, properly organized and adequately resourced, possesses industrial potential that dictatorship cannot comprehend, much less match.